Chapter 25, Example 3. We have reports from 4 colleges on the post-graduation activities of their 2006 graduating classes. Question. Are students' choices of post-graduation activities the same across all colleges? When we collected this, we already separated them by college, and we surveyed people at each one. Then we said, are they the same across all colleges, which means we're doing a test of homogeneity. The main difference there is the design. So we'll start by calculating our expected values. We had 1,456 people, 685 were going to be employed. So that gives us 210.77 for the expected for employed. 466 over 1456 times all the agriculture gives us 143.39 for grad school, 93.85 expected for others. For arts and science, we have 227.71 that will be employed. Those going to grad school, 154.91 would be our expected value there. We would expect 101.39 to choose another field. For engineering, we would expect 175.96 to go on to employment. 119.7 to go to grad school, and 78.34 to choose some other path. Finally, for ILR, we'd have 70.57 employed, 48.01 go on to grad school, and 31.42 choose another path. Most importantly for us there, all those are at least 5. So let's write our hypotheses. The null hypothesis: student postgraduate activities are the same across all colleges. We're trying to show that they're actually not. So our alternative hypothesis is that student postgraduate activities are not the same across all colleges. The data are counts, and the expected cell count for each cell is at least 5. The sample is not random, but I will assume it is representative of all recent graduating classes the conditions are met, I will use a chi-squared model for a chi-squared test of homogeneity with 4 minus 1 times 3 minus 1 comes out to be 6 degrees of freedom. Degrees of freedom will equal 6. When we calculate this with technology mainly, chi-squared equals 93.6567, which provides us with a p-value of 5.263 times 10 to the negative 18th power. So that's an incredibly small p-value. Let's see how to do this technology, because it's a tad bit different with homogeneity or independence. So we're going to get a matrix. Next to the 9, there's a little template. You press that. The middle spot will be for matrices. We have 3 rows and 4 columns. So we're going to type in our table that we had the values in here. We don't have to do expected values because it will do that for us. So we get 209, 198, 177, and 101, which was for the employed. And then we'll do our grad school row, which is 104, 171, 158, and 33. Finally, we do the other row, which is 135, 115, 39, and 16. So we need to store this as a name so that the handheld knows how to calculate this. So we name it observed. You're going to hit second variable, gives you a little arrow, and then type in letters OBS. Now we go to statistics, stat tests, and right there a chi-squared two-way test. Choose the matrix that we just stored, which is observed, and hit OK. There's our data, chi-squared, p-value, the degrees of freedom. It also tells us exp matrix, so that's a variable we can call that will show us the expected values. So you can use that to find the expected values. And the comp matrix gives you the components, individual components. So we're going to do the expected matrix here so that you can see that it's the same values that we typed in. So you can simply do that to check your expected values. My p-value is very low, and I will reject the null hypothesis. There is evidence to suggest postgraduate plans are not the same across all colleges.